Pyrolysis is a chemical reaction converting material into its basic hydrocarbon elements under heat, pressure, and importantly, in the absence of oxygen. Pyrolysis is not incineration. This video demonstrates this process within a typical clean seas pyrolysis conversion facility. Mixed plastic waste is loaded into the pyrolysis reactor, which is then sealed. An overhead crane places the reactor into a kiln or furnace to be heated to approximately 1100 degrees Celsius to begin the pyrolysis reaction. The average residence time to complete the reaction is 10 hours. As the plastic is turned into a gaseous vapor, the gas begins flowing into a cyclone separator where heavier elements like wax and oil are separated and stored. The light hydrocarbon gas then flows through the condensers where these gases are cooled and subsequently condensed to form liquid hydrocarbons, or ultra-low sulfur oil, which is collected in the tanks below the condenser. A vacuum system generates negative pressure in the system, reducing the pyrolysis reaction time, increasing the yield and quality of fuels, decreasing the energy requirement, and making the entire process safe. The process gas scrubber cleans the uncondensed hydrocarbon gases and separates any remaining sediment. The cleaned uncondensed gases from the scrubber are recirculated in order to maintain furnace temperature to continue the reaction. Excess gases are stored in a gas storage system. The stored gas can be used for initial startup of the furnaces and also for power generation using a gas-fired electrical generator set. The oil collected in the process oil tank is sent to an oil-water separator tank where the moisture settles to the bottom of the conical section. The oil is then passed through a 5-micron oil filter where the solid impurities in the oil are filtered out. The filtered oil is then pumped into the final storage tank, awaiting distribution as an ultra-low sulfur fuel. Once the pyrolysis reaction is completed, the reactor is removed or swapped from the furnace and placed in the cooling station to be cleaned and reloaded. Preloaded reactors are then placed into the furnace to begin the process all over. This swapping of reactors allows for a more efficient plastic conversion process, reducing heating costs, reducing plant operations footprint, and maximizing facility operations.